Almost 25 years ago, I was arrested for hacking. It was 1998, and using my trusty 14.4K modem, I'd hacked into a corporate network over the phone lines and got myself caught. So there I was, sat in a police station, and I'd just finished giving my statement to 3 police officers who didn't understand most of what I told them, but were still sat trying to decide what to charge me with. And after a few minutes discussion, they told me they were going to charge me with 1 count of fraud for every time I'd logged in with someone else's username. 4 counts. And they were going to charge me with 1 count of theft for every individual file I'd downloaded. 57 counts. So there I was, found myself 17 years old when they told me that I was going to go to jail for 270 years. I'd just been told I was going to go to jail for the rest of my life. My first thought was, my mum is going to be pissed. So I managed to avoid jail, but this whole experience did tell me that hacking probably wasn't going to be a great career. So later that year was the first time I got paid for building a website, and I've been working on the web ever since, mostly doing SEO, search engine optimization. Incidentally, if you think people react badly when you tell them you're a hacker, try telling people you do SEO. And so, why am I telling you all this? The point is that ever since a young age, like Harley just said, like I've had that hacking mindset. Once a hacker, always a hacker. I've always had that hacking mindset, but I haven't got the hacking experience. I only signed up for HackerOne during the pandemic. And everybody here in Vegas, you're all more experienced, better hackers than I am. But sometimes that can be an advantage, right? Because if you've got that hacking mindset, but you don't have the experience, you might approach problems and try to solve problems yourself and end up finding a lucky new way of doing things. And that's what I want to talk about today. I want to talk about an approach that I've been using to find cross-site scripting bugs that I've not seen written about or talked about anywhere else. And it's got me a whole bunch of bounties. So I'm going to talk through a quick introduction to fuzzing, specifically the difference between 2 different types of fuzzing, black box fuzzing versus coverage-guided fuzzing. And then I'm going to talk through a couple of case studies where I've used this exact approach on bug bounty targets, got real bounties for it. And then I'm going to wrap up with a framework so that when you're back at your desks next week or whenever, you can start doing this straight away. Okay, so let's start off by talking about fuzzing. And so I really like this introduction from the amazing Vicky Lee. If you haven't bought a book, you should. Fuzzing is a way of finding bugs using automation. It involves providing a wide range of invalid and unexpected data into an application, then monitoring that application for exceptions. So basically, you throw a whole bunch of unexpected input and you see how the app responds. And those inputs can be things from word lists through to ranges of numbers or bytes, or by mutating other inputs, taking inputs you've already tried and flipping bytes or splicing them together or whatever it might be. And so most of you will be familiar with what's called black box fuzzing, which is something like Burp Intruder, where it fires a whole bunch of stuff and you see how the app responds. The important point about black box fuzzing is that you can't see what's happening inside the app itself. You try different inputs and you can see if it responds differently, but you can't see what's going on inside. Whereas today I want to talk about coverage-guided fuzzing, which is a different approach, which is where you sort of instrument the target so that you can see inside whatever it is you're fuzzing, and you can see how does it respond to different inputs. Specifically, you can see when you provide a certain input, which lines of code get executed for that input. And then it's called coverage-guided because coverage is the metric you care about, which is the aggregation of how many lines of code have been executed in total across all of those inputs that you've tried. And so when you find a new input that extends your coverage, it executes a line of code that hasn't been executed by any of the previous inputs, then you add that, well, firstly, that increases your coverage metric, but then you add it to your corpus, which is just the collection of inputs that the fuzzer has identified are useful in increasing the coverage, executing new lines of code. So this whole approach to fuzzing is focused on trying to maximize how many different lines of code are going to be executed inside the target in total across all of the inputs you're trying to get into the nooks and the crannies of the code base. So you've got two types of fuzzing: the black box, where you can only see the response. You've got the coverage guided, and that's what we're going to be talking about today. We're going to be talking about using this coverage guided fuzzing approach to fuzz cross-site scripting sanitizers. So these are libraries that you can use whenever you're taking user input from any source and you want to sanitize, you want to make it safe, make sure there's no scripting payloads in there. And the fuzzing techniques I'm going to show you today, I've found zero-day bypasses in at least 4 of these sanitizers. Okay, so that's fuzzing. It's fairly simple. So let's actually apply it to a couple of different targets. So the first one, this was early on in my career. Once I registered for HackerOne in the pandemic, I started digging around this online holidays website. And after a while, I found a cool bug where I could reflect the cookies back in the HTML content. So being the naive young hacker that I was, naive, I'm one of the oldest hackers here, I wasn't young, but being the naive hacker I was, I decided, well, I haven't got any way to abuse this because I don't have a cross-site scripting payload, but I'll submit it anyway because surely they want to fix this, right? But sure enough, the triagers came back and said, well, let us know when you can actually do something with this, when you've got a working attack vector. So I went and I did what I thought hackers were supposed to do, which is copying and pasting XSS payloads into every field I could find on that website. But after a couple of days, I was getting bored and nothing was happening. So I stood back and I tried to think about playing to my strengths and thinking about what interesting functionality had I seen on that site. And one of the most interesting pages in my mind was a page where you could, if you were registering your own property on the site, you could customize what is the content of that, and you could use limited HTML. And this, because they allow you to use HTML, now they've put the onus on them to make sure that they're sanitizing the HTML that you put in. So then I wanted to know how they're sanitizing it. And I looked in the source code, the JavaScript source code on the site, and I could see they're using a JavaScript client-side sanitizer to clean the HTML you provide. But because it's in the code, I can see exactly what sanitizer it is. So then I can go and I can download that sanitizer. And once you've downloaded the sanitizer, then what you need to do is configure that sanitizer so it's running in the same way as the target is using it, because every different target is going to configure a cross-site scripting sanitizer differently depending on which HTML tags or attributes they're going to allow. So with this target, I just went back to the source code and literally copy and pasted the configuration. And at this point, this meant I could now test locally. I could run payloads locally on my command line, and I could see that it was sanitizing those in the exact same way as the website, the target. So now I could test much faster. I didn't have to go to the site, et cetera, et cetera. But more importantly, it meant I could fuzz. I wasn't 100% sure what fuzzing meant, but I knew that fuzzing meant that you've got to throw loads and loads of input at something. So I was like, that's going to be good, right? So I'll go and I'll Google JavaScript fuzzer, and I found JS fuzz. And so now I had a fuzzer which throws lots of inputs, and I had the sanitizer set up locally, so now I could theoretically throw lots of inputs at it. But the problem is that fuzzers aren't designed to find cross-site scripting vulnerabilities. Fuzzers are a software tool that are designed to identify crashes normally, for coverage-guided fuzzing at least. Sometimes those crashes might be security-related, like an overflow bug or something, but typically they're looking for any sort of crash. And so how are we going to solve this? How are we going to make the fuzzers look for cross-site scripting? So this was the 20-odd lines of hacky JavaScript that I used to solve that problem, and I'll talk you through it quickly. So Firstly, if you're going to use coverage-guided fuzzing, you have to write a fuzz function, which is what the fuzzer is going to pass every input into. It's going to put the input into that fuzzer, wait for you to do something with it, and see if it crashes. So this is the fuzz function, just taking some dirty HTML in this case, the payload from the fuzzer, but in reality it'd be whatever the user's putting in. And then this is just the configuration for the sanitizer. This is just a simple example, but you can see it's showing what tags and what attributes are permitted. And then you're basically done. And now you can take the dirty HTML, you can put it into the sanitizer, and theoretically you should get some clean HTML out. And so the next step is important. You take that clean HTML and you need to build a DOM. So we need to look at this this HTML in the same way as the browser would do. Browsers don't look at HTML as just a naive string. They build a DOM, a tree-like structure. And so we're going to use a DOM library just to build that same DOM in our script here. And once we've done that, at that point, we can ask the DOM library to run query selector commands. Is there a script tag? Is there an onload or an on-error handler anywhere in this payload? If there is, we're going to throw an error. We're just going to deliberately crash the program because that's what the fuzzer is looking for. It's looking for crashes. And whenever there's a crash, the fuzzer says, oh, this is an interesting payload. I'm going to report it back to you, and I'm going to put it in the corpus. So at this point, we've sort of co-opted the fuzzer into looking for cross-site scripting payloads rather than crashes. And because it's coverage guided, it's trying to find a way to execute every possible line of code. And it's typically in these sorts of deep edge cases where we'll find our cross-site scripting gremlins, where we'll find these sort of bypasses. So at this point, I actually just went away and I started the fuzzer. I thought I'd done great, but nothing happened, and I got frustrated. And that's because the fuzzer needs to be given some clue as where to start in terms of inputs. So for myself, I just started off by going and downloading a whole bunch of cross-site scripting payloads and using those to prime the corpus. The corpus, is, if you recall, is just the inputs. But that's not going to be enough because you need the fuzzer to be generating complex HTML payloads. So you can't just use cross-site scripting payloads, you need to put some HTML snippets into your corpus as well. And at that point, the fuzzer is going to start mutating them and splicing them, building pieces of HTML. So at this point, you can start your fuzzer, and now you'll see something like this. You'll get periodically a new row of data, and it's going to show you several columns of information. The COV is the coverage metric, so it's showing how many lines of code has it executed in total across all of your inputs. So you've got the corpus, which is here 6425. There's 6,400 odd entries in my corpus. And then you've got execs per second. How fast is it getting through input? So in this case, just over 500 a second. So that's, what, close to 2 million payloads it's trying every hour. And you can just leave this running day in, day out. So it's quite sort of brutal in trying lots and lots of payloads. At this point, your fuzzer is running. And I think it's been scientifically proven that if you watch the fuzzer whilst it's running, it won't pop. You won't get any output. So it's important not to watch it. So at this point, I recommend going and getting in the bath. Your fuzzer's being productive. You don't have to. Have a soak. Oh, going in the wrong direction. And so after 4 days on my first attempt at this, the fuzzer spat this out, said, this makes the program crash. And I thought, well, that looks suspicious. It's got a script tag in there. And I was like, how is this possibly working? And so I dug into it, and basically the space after the equals and before the quote confuses the sanitizer in this case. The sanitizer sees something like this. It sees a target attribute with no value. Then it sees an href attribute with this script tag, but the script tag is harmless because it's just the contents of an href attribute. What the browser saw is something like this, a target attribute that has an href as the value, and then this script. So at this point, the fuzzer had spat this out. I'd understood how it was working, and so I went to try it against the target. To my delight, it worked, and I got my highest bounty to date, and I was pretty excited. And so a few months later, because this approach had worked, when I came across a similar scenario on a video conferencing platform, I knew exactly what I was going to do. Once again, they had an area where you could write some custom HTML, free-form HTML, so I put that in there, and then I needed to identify the sanitizer like I'd done the first time. With the first example I showed you, the sanitizer was client-side, so you could just look at the source code and see exactly what it was, how it was configured. With this target, the sanitizer was running server-side, and so I couldn't do that. And so instead, what I did was I looked at the API traffic going back and forth, and I could see in there were some interesting keywords that might mean something. So being the SEO expert that I am, I just put them into Google, and the first few hits were all from this Java HTML sanitizer written by the OWASP team. So at this point, I was fairly confident this is the sanitizer that the target is using. And so now, just like with the first example, I need to go away, and I need to work out how is this configured. And so with the client-side sanitizers, you can look and see in the code how they're configured. With this sanitizer, I couldn't do that. And so instead, what I did was I cobbled together this little Python script that basically makes every possible HTML tag with every possible attribute on there. It squashes them all together. There's a tool on PortSwigger that does something similar. With the PortSwigger tool, it basically makes an A tag with an href, an A tag with a source attribute, an A tag with a title, whereas mine made a single A tag with title, href, source, etc., etc. Doesn't matter how you do it. So then, once you've got that, you go and you put that into the sanitizer. You might have to break it into several chunks. You run it through the sanitizer, and the sanitizer spits out, no, you can't have this, you can't have that. You're allowed this attribute and this attribute and this attribute on this tag. And so at that point, you should have a good mapping of what attributes are allowed on what tags. And you can go, and with the Java sanitizer, you can go and configure the sanitizer to mirror exactly what the target was seeing. With the first example I showed you, that was a JavaScript target. The sanitizer was JavaScript, and so I used the JavaScript-based fuzzer. For this example, it was a Java-based sanitizer, so we needed Java-based fuzzer. So I just Googled around, found Jazza, which seemed to do the job. Once again, you need to write your fuzz script, and this, we're not going to talk through it. It basically does the same thing as the one I talked you through. It cleans the content through the sanitizer and then builds a DOM, and it checks, does it crash? Is there a script tag? If so, we're going to force a crash. And then you get it, let it run. This is Jazza in action. You'll notice it looks very, very similar to JS Fuzz. They mostly look identical. So now your fuzz is running. At this point, back to the bath. Curry in the bath. I like to eat curry, and I like to watch Netflix, so I do those together. I call it Netflix and dal. But I also like baths, so I like to do them all together. Sunday afternoon, curry in the bath. I don't actually have a cool handle on HackerOne. I'm just Tom Anthony. But if I did, it would be curry in the bath. OK, so your fuzz is running. You're not watching it. My week looked something like this. And it was about 10 days in this case that the fuzz was running before it spat out this beauty. And so I was thinking, what the hell is this? So this is a lesson if you try this. Don't expect your fuzzer to be spitting out nice, clean content. Your fuzzer is trying to create inputs from mashing all your other inputs together in random ways. So you get a lot of junk like this, with the payload is buried somewhere inside. With the initial case study I showed you, that was the same. I showed you the cleaned up version, but the initial output was a whole lot of junk wrapped around it. So when you clean this up and you minify it, the payload in this case was this, which has a fairly obvious script tag sat there in the middle. But if we format this a little bit, we'll see the script tag is inside the style tag. And so, OK, so the browser, the sanitizer, sorry, is sure enough, treating this as harmless CSS because it lives inside the style tag. However, if you look at HTML spec section 13.2.6.4.16, which I'm sure you're all intimately familiar with, it describes how a browser should handle the case when there's already an open select tag on the stack. And it's got a whole bunch of rules for how to handle option tags and opt group, etc., etc. The very last rule says this. Anything else, this is a parse error, ignore the token. And the style tag wasn't listed in any of those rules. Ignore the token means the token itself, so that means ignore the tag but not its contents. And so the sanitizer was saying, oh, this is harmless CSS. The browser was saying, well, this style tag's not allowed here, so what we're going to do is remove it from the DOM, but we're going to keep the contents. And so from this absolute mess, we ended up with this relatively beautiful little payload. And I think that's a really good example of how this sort of coverage-guided fuzzing can find these strange edge cases. And yeah, it turns out it's quite powerful. Okay, so I reported this to the OWASP team. They fixed it quite quickly. I got my first CVE, which was very exciting. But it turned out there was a whole bunch of derivative sanitizers. I'd broken a sanitizer in Java, but there was a Ruby sanitizer, a Python sanitizer, a Golang sanitizer that were all vulnerable to this same payload. So suddenly there were sort of cross-site scripting gremlins everywhere. I reported this to the program. I got my next new biggest bounty, so I was pretty excited. And so at this point, it's tempting to say, okay, well, we found the cross-site scripting, we defeated the sanitizer, and so we can step back and chill out. But there's no reason to think you found all of the bugs at this point. I waited till the sanitizer was updated, and then I put it back into the fuzzer, set it off running again. At this point, you should know what's coming, back to the bath. The bath is quite critical in this whole process. Make sure you don't skip it. At this point, in this case, it took several weeks. I think it was like 4 or 5 weeks of the fuzzer running before it found anything. I didn't spend the whole 4 or 5 weeks in the bath. But after 4 or 5 weeks, it spat out this massive payload. This was the minified version. After I cleaned it up and minified it, it's over 100 tags. So I've got it's a really big payload, so I've got a really big cross-site scripting gremlin because I'm clever like that. I can't show it to you because this hasn't been fixed yet, but the payload basically worked by being a super complex HTML mutation that got the sanitizer confused about what state it's in and bypasses the fix for the previous payload. And so that led to 3 more bounties because I was able to chain it in a bunch of ways, which was very exciting and hopefully sort of persuades you that this type of approach is very powerful. Okay, so I've talked you through those few case studies. And so now I want to quickly just recap the framework. I'm going to go through this quite quickly. This is just so that when you're back at the desk, if you grab the deck, you'll have a sort of framework of what to do. Okay, so basically, step 1 is identify the sanitizer. Is it client-side? Then look in the JavaScript. If not, look at the API traffic back and forth. If that doesn't work, you can use fingerprint payloads, which are payloads that are sanitized differently by different sanitizers. And so you can use that to identify what sanitizer might this be. Determine what the config is. What tags, what attributes are allowed. Are there any custom handlers for certain tag configurations, etc.? And then at that point, you know what the sanitizer is, you know what the configuration is, so you can set it all up locally, you can find a fuzzer to run it against, and then you can kick off the fuzzing. You need to be patient. As I said, the last bug I got was 4 or 5 weeks of fuzzing before it got a hit. And so, yeah, be patient, spend a lot of time in the bath. Do track the coverage over time. Over time, if the fuzzer is running, then you should see the coverage slowly ticking up. Sometimes I'll go like a week without getting an increase in coverage, but then it'll find something and it'll find a new bit of code that hadn't previously been visited. So track that over time. If it's not going up, you probably need to put something else into your corpus. Okay, so if you are going to do this, there's a few sort of advanced things to consider. The first is the coverage metric is based on what you choose to instrument. And that basically means what lines of code do you want the fuzzer to pay attention to. You should not instrument just the sanitizer you're targeting, but you should also instrument the DOM library that you're using to build that DOM. The reason being that there'll be some payloads that the sanitizer can't differentiate. It treats them basically the same. But the DOM library recognizes that this actually has a different behavior and so executes different lines of code. You want to capture those cases. Custom mutations. So sort of skipped quite quickly over how fuzzers mutate inputs. So most fuzzers will have a whole bunch of built-in mutations where they will flip bits, remove bytes, take two of the entries from the corpus and splice them together somehow. That works well, and I found bugs like that. But what I also found was that you could do even better if you write custom mutations for your fuzzer that are HTML specific. Things like add a tag here, add a cross-site scripting payload there, remove an attribute, whatever it might be. It makes it a little bit more sort of focused and guided, and you'll get results quicker. So I mentioned that fuzzers are designed to find crashes. They're not designed to find cross-site scripting. But the crashes can also be useful. Sometimes the sanitizer will actually crash. I had a case like this where the sanitizer was crashing, and when I tried it against a target, it just hung the thread on the target. So for 60 seconds, the web server didn't respond on that thread anymore. So I submitted that, got another little bounty. So yeah, a couple of final points. The first one is that if you do this, you need to sort of look after your corpus, tend to it like you tend to a garden. Some of the fuzzers can be quite aggressive about adding things to the corpus when they think they're interesting, because they might be a smaller payload that executes the same lines of code that a previous payload did. But what that can mean is you end up with a corpus that has, in this case, almost 500,000 entries in it after it's been running a couple of weeks. So periodically, you need to stop it, and you need to dedupe your corpus. But there's not going to be any duplication in there, but some fuzzers will have a function built in where you can say, give me the minimum set of my corpus back that still maintains the coverage that I've got right now. And then, yeah, I think this is my final bit of advice. If you get heavily into this, then what you should do is you should have your fuzzer set up fuzzing multiple sanitizers at the same time. So it takes a single payload, but it tries it in multiple different sanitizers. The reason is, otherwise you're going to end up with multiple different corpuses to look after. But also, there's sometimes cases where a payload triggers an extra line of code in one sanitizer, and then later on, and so that input is put into the corpus, and later on, it proves useful against one of the other sanitizers. So definitely something worth considering. So that's me. I'm hoping that I persuaded you that this is something that's worth investigating, especially if you come across sort of hardened sanitizers where they are permitting some level of HTML. This is a great approach to take. If you have any questions, you can either grab me here at the conference in person, or you find me on Twitter, Tom Anthony SEO. I decided to put SEO in my Twitter handle, and that's a decision I'm going to have to live with. But yeah, you can find me there. Thank you so much for your time. Cheers, everyone.